Hey, what's up everyone? Lucas here. Obviously, you're probably wondering what's going on with my face, and that is because you're seeing it through a GLSL shader. This is something I've been working on the last couple of days, and I just thought I'd make a video and talk a little bit about it and show you how it works. If I lower this setting a little bit, you can see that actually this is made up of a bunch of photos. These photos are just straight off of the internet, just got like a Imgur photo dump that I found. Downloaded it. This is 2,000 images. No, this is 1,000 currently. Um, but yeah, this is a really cool filter, and it's been kind of turned into a tool here, so you can actually plug in your own photos, and you can set up your own parameters here, and then create your own look. Um, you can see up here, this is me unaltered, and this is the feed. And with this, we have these sliders right here specifically that adjust the live feed itself. So you can see we're adjusting brightness, gamma. For different types of content, you may need to adjust your raw footage accordingly to get the best look. So that's why that's there. And then RGB noise is pretty simple. Basically, you see how all these similar looking squares, textures are kind of congregating together. It's because we don't have enough samples to really get a fine assortment of samples. If we had like 4,000 or 6,000 images, we'd have a much better spread. But since this is 1,000, one quick fix is just to add a little bit of noise in there. Although the noise doesn't look great, in my opinion, I think it's not that great because it's being applied unevenly, or it's being applied evenly to both low, middles, and highs. I think it really should just be applied to the high values only. Um, maybe I'll try that here at the end of the video, but anyways, that'd be an easy thing to add. Just haven't done it yet. So up next, we have a couple other effects. This is the exact same system, but now it's using a bunch of different images of text characters. Actually, this is just the numbers um, and a few symbols. I think just 26 characters in total. Uh, But this all works the same way. You can adjust the black level, you can adjust the gamma. You can see the noise effect a little bit more clearly here. You can see it's really doing its thing down here, which is pretty neat. So there's lots of filters out there that give you the ASCII look on ShaderToy. You can even find apps to do it, but the point of including this is just to show you that you can do this with a wildly different set of source images. So we have random images, we have ASCII, and you can pixelate this as well, very quick and very fast. And then here we have a bit of a different effect. This one's kind of cool. It's probably my favorite at the moment. And this is essentially a set of cards, flip card effect. I've essentially rotated a rectangle while scaling it to kind of give you the value range from like black to white. Then we've also kind of copied that essentially to get maybe 12 or 14 different color sections along the hue range. And the reason why you're seeing this hot spot on my head right over here, I don't know if you can see me pointing, let me lower the resolution, right here, the reason why that's bright yellow when my face in real life is actually just kind of a light, desaturated kind of white, is because I don't have an unsaturated white color tile to source from. So this is actually the closest thing that is in the set of images that matches my face in that area. So kind of interesting. It might be a cool effect if you're doing it intentionally, but it also might be kind of wrong if you're trying to go for an accurate look. So last effect down here is basically the same as number one, but instead of pulling from a bunch of images, I've actually pulled from frames of a video. You might be wondering what video. I'll just zoom in here, and I'm sure you'll recognize it if you've seen the music video before. It's called The Artist is Blockhead. Song is Music Scene. But the reason I tried this was to see what would happen with a more consistent color palette. And it actually does create a nice look. I think it's a little bit more aesthetically consistent for one, but it, you know, especially on detailed areas like my hand, I think it's really kind of neat looking. On more flat, constant areas, yeah, it's not as interesting, but It really depends on your content and your source footage. So anyways, that's a bit about how this works in the front end, just to kind of dive in and show you how the back end works, how it looks. If I go up to the top level here, we've got our camera feed coming in, we've got screen grab, which I was playing with that earlier. Um, anyways, so basically over here we have 4 different examples. Let me pretty much explain the first one and I'll touch on the others just briefly. A few things that are different. This is the audio, you can ignore that for now. So we start over here at the left, we have a folder full of images. Alright, it's being loaded in from our user-defined folder in the front end. And then over here we're limiting our selection to no more than 2048 images. And the reason why we're limiting it to that is because the Texture 3D, as I just found out last night, does a maximum of 2048 textures, which makes sense. It's limited to something. We could get around this limit by copying these. I'll come to this later, but we could get around this by copying these and doing some different math in the shader to pull samples from different inputs based on what sample we're looking at. But for now, 2048 is fine. So a little bit further down the line here, we're doing me.time.frame, which you'll recognize this if you've ever cached anything before. It's essentially just what you have to do to cache something in a top that does caching. So what this does is for every frame it changes the path, right? And so we can see that our kind of movie in file here is just flying through all the different images. We're fitting that to a 1280 by 1280 size, a square, and then we're doing a high quality resolution downscale to what we've set in the front end, which is 128 by 128. So over here is where things kind of start to get a little bit more interesting. We have an analyze top, which is giving us our average, right? This is a 1 by 1 resolution top, so there's basically nothing here except 1 pixel. And then this is holding, these are our 2 texture 3Ds, right? So the difference between these, if you haven't used them before, or if you just aren't familiar with touch, these tops can hold X and a Y and a Z pixel, right? So we have 128 by 128 by 1000 deep. Right, so if you imagine this as like a swimming pool, and the deeper you go, the further towards the top you get in terms of images. This is laid out in a grid just so you can see them, but really these are best thought of as along a z-axis in terms of their position. So anyways, this would be number 1 or 0, and this would be 1, 2, 3. This would be like 32 or whatever's over here, and basically when you get to the very top, this is like 1000. So that's your entire set of images. They're in no particular order, alphabetical coming off the hard drive. And then here we have more or less the same thing here, but instead of the full 128 by 128 image, we actually just have a 1 by 1 pixel that has the average color of that entire texture. So a middle mouse click, you can see this is a 1 by 1 by 1000, so this is very small in terms of memory. It's not even registering as 0.01 megs. This one, by the way, if you're curious, is only 62 megs for 1000 images, 128 by 128. So pretty light, surprisingly, on the GPU RAM, but you can definitely get into trouble if you go too high with your fit size. So once we have that stuff stored, we're going to pass it into our shaders, and up here we just have our live feed, right? This is me coming in at 640 by 480. I'm doing a fit, and then a fit here to my output res, which is 1920 by 1080. And then I'm doing a resolution downscale to get this to the pixelated size that you saw in the perform window. So this resolution that you see here, 64 by 32, that's what we're setting this to. Because we're going to do math on this and we want this to match the output pixelation that we're going to eventually have. So here we're just doing some modifications to our source footage. You can insert your own stuff here, blur, noise, levels, etc., etc. And so these are the shaders. These are the 2 things that are most important in the network, obviously. The first one here will actually just calculate the slice index, right, of this 3D texture that is closest to every pixel in this image. Let me actually go and put these to nearest. You can actually see this a little bit more clearly. So we have these pixels here, right? And so let's just take this pixel, for example. This pixel is the value of roughly 0.2, 0.23, and 0.22, right? And so that color, it corresponds it has to correspond to something in this array, right? So we need to figure out which one of these items it's closest to in terms of color. When I say closest to, another way of thinking about this is, we have a red, green, blue pixel. Think of that as a 3D coordinate, right? Like an XYZ coordinate. Over here, we have a red, green, blue pixel. So again, let's think of it as an XYZ coordinate. And when you have, two coordinates in 3D space, what is the distance between those two coordinates? And so maybe the first coordinate we test is like 10 units apart, and the next one's 8, the next one's 6, the next one's 2. And maybe finally we get to one that's 1 unit apart, and that is our closest pixel. That's the color we want to represent with that pixel. So that's what this shader is doing. That's why it looks all kinds of wonky. If I throw just a math top here, so you can visually see what this actually looks like. The reason why you can't see anything but red is because these are actually like well beyond the 0 to 1 range, right? These are in the 0 to 1000 range because that's how many textures we have. And so each of these pixel values is representing our slice in the 3D texture here. But just so you can see it, I basically, so if I multiply this by 1/1000, which is exactly what would get us back to 0 to 1, we have kind of this kooky looking texture, but you can actually still see my representation vaguely, even though it's very jumbled. And the reason why it's jumbled is because we're no longer going from bright to dark or dark from bright. We're essentially seeing the ID of the texture that we want to sample. So this means nothing to us here, but this information is very important down the line. And if you want to look at the shader code, of course, you can grab this file and you can really dig into it. These are all comments, so you can just kind of look through it and try to understand what's happening. But just to give you a general idea, and again, I'm kind of coming at this from a more novice perspective myself. Over the last couple months, I've been learning shader code, so I'm explaining this hopefully to those of you who haven't really had too much experience. So, if you're experienced with shader code, disregard what I'm saying. Maybe there's a better way to say it, or maybe you already understand this. But essentially, when you write code in main, you're writing code for one pixel. Really, is the best way to think of it. You're not writing code that's going to iterate over the entire set of pixels, because this code gets executed for every single pixel independently of every other pixel. So if I were to shrink this down to 1 by 1 pixel, this code would just operate on that 1 pixel. If I were to expand this to its current size, which it is, this code would get executed 57 times 32 times. But it would be executed in parallel to each other, which is why GPUs are so fast. So anyways, the reason why I say that is for loops can be kind of confusing in shaders, but essentially this for loop is being run for every single pixel in this GLSL shader at the same time. And so what's happening is, we're starting off with a high value of 9,999 for our current depth and our minimum distance. And then what we do is we sample each of our average colored tiles, right? Which is, remember, it's this tile. We're going to go through each of these 1,000 layers, and we're going to test each of those layers against the corresponding pixel in our live feed here, or rather our live feed here. And so every time we iterate through this for loop, we're going to say, okay, is the current distance we just found less than the distance we have set, right? And this is why we set this to a high number up here, because for every time we find a smaller distance, we update this variable with the new distance, right? So we're essentially doing a brute force sorting method, and we're finding the smallest distance by iterating through every single one of these. So eventually, at the end of the for loop, after 1,000 iterations, we can be sure that we've found the smallest distance, right? And so every time we do this, we store the index we're at. So not only do we have the shortest distance, we also have the index of the shortest distance, right? And so this current depth is actually getting written to the red channel right here. And this is all just not important stuff. I'm basically just setting those to 0, but what we get is a red channel that gives us the index value, nothing else, of which of these textures to use. And that's honestly the hard part, or the slightly longer part. Once we have that, we want to pass into our Mosaic shader here, which you can see is what you saw on the camera. We want to pass in our unordered original texture 3D of images. And we want to pass in our distance GLSL here. So what's happening in here is quite simple, actually. We have we're basically modulating our UVs, right? Because when you start out, your shader is from 0 to 1, 0 to 1. But we actually want to sample a lot of different tiles. So we actually need to multiply and modulate our UVs so that we have a lot of little 0 to 1 sections kind of scattered throughout. So what we do is we set up the size of our repeats, and we set the p-value to our slice ID, which is what we passed in. ST and P, another way to look at those is U, V, and W, right? So we have our U, which is left to right, our V, which is up to top to bottom, and we have our W, in this case, which is our depth into this guy here. So that's essentially what's happening, and that's why we have those 3 coordinates. And then once we sample, once we create our UVs, or we modulate them, we can pass that into our sampler, and we can get our image, and we can just throw that out to our color channel, right? And that's what we've got right here. That's just the basic gist of how that works. That was a little bit longer than I think I probably should have gone on, but you get the idea. So, diving into some of these other examples, won't be much more to show you here, but just a quick, brief look. I've got a text top here. As you can see, it just cycled through some characters. And the way we're getting those characters is we're taking and evaluate that with the table. So this has got 255 rows, doing a char of me.inputCell.row, which gives us the character that associates with that number. So 33 is the exclamation mark, 48 is 0, so on and so forth. We grab a subset, and we do me.time.frame, and then we can cache and send that into our network just like everything else. So here you can see we have just a few characters, and we have our values and average, and everything else after that is exactly the same. This one is a little bit different. It's worth mentioning how it's set up as well. Again, you can explore the math and the expressions more on your own, but essentially we put some expressions together that repeats this animation, which is, let's see, it's spanning 32 frames, right? And it's repeating it, I forget exactly how many times, 11.25 or like 11 or 12 times. And so every time it repeats this cycle, you can see the hue actually shifts by 11.25. And so when we cache that 2,048 times, we get this kind of flip card deck or array of textures that we can use in our shader, right? And this is a little bit easier way to visualize it. These are average colors, so it's essentially just kind of looping through each of the colors, hue ranges, and giving us value, but we have no saturation, so there is no saturation in this look, but that's okay. It's kind of a neat look the way it is. Last but not least, we have our video frames mosaic. This one's pretty simple to set up. All you really have to do is you have to throw a video file in here, um, and it's going to go through the fit, blur, and res. You might need to adjust the math. You will have to adjust the math under index. It just depends on how long your footage is. I kind of just manually figured out this number. I didn't actually calculate it, but anyways, the end result is, you know, a bunch of frames from this music video, and as you can see, we have the end of the video and the beginning of the video is kind of the same color tone. We have a lot of this explosion color in the middle, and then that kind of fades out. So it's kind of neat to see this, you know, here, this progression of what the video looks like. This would be maybe the beginnings of some kind of video analysis software programming that you could come up with that looks through the progression of hues, and maybe it comes up with some kind of like math or the algorithm to kind of like understand what this means. But anyways, that's a topic for another time. This is all essentially getting used the same way with the two GLSL shaders, and there it is. So that's essentially it. These all have custom parameters. You can access all these from the front end as well through the parameter comp. Yeah, so that's it. I hope you enjoyed this video. I hope it was helpful. Again, you can grab the file, play around with it. Please do. Let me know what you come up with, and yeah, can't wait to see what you do. All right, thanks.